Thank you very much for the introduction. So this is joint work with my advisor, Professor David Evans. So nowadays, a lot of modern applications uses lots of third-party components in their application. These are functionalities include advertisements, analytics, and some social network widgets such as Facebook or your Twitter feeds. So these components are actually directly embedded into the page shown here, because they will need access to some of the content of the page. The other interesting fact here is that a lot of sensitive information about the user could also be displayed on this page as well. This includes maybe your username, a password, your email address, or some worst case, maybe your financial information, depending on different sites. So because these elements coexist together on the same page, the untrusted third-party component would have access to all these sensitive information, and they can possibly manipulate them or retrieve them and send them away to a remote party. So the fact that JavaScript has some features such as eval or document.write makes this a very hard problem to statically analyze what the third-party JavaScript is doing. And also because of widely used compression and obfuscation, it is very hard just to look into the JavaScript and determine what they're doing, basically the third-party scripts are doing. So to this end, we propose a script inspector. This is a tool, a set of tools that help developers or concerned users to understand the behavior of third-party JavaScript better. So the centerpiece of this tool is a modified Firefox browser, which has instrumented APIs. And they would intercept critical calls to resources such as DOM, cookies, or network access. And they would output a trace, which can be visualized by the visualizer component. The visualizer is an extension to the script inspector, and the site administrators or the concerned user can view the highlighted elements of the page, which is being accessed by the third-party JavaScript. A second use of Script Inspector is that it supports a range of security policies, and these security policies can be used to monitor the third-party JavaScript in a script monitoring phase. And in the script monitoring phase, Script Inspector can take input from simulated sessions or reverse proxy, so this will be real-world traffic. And the Script Inspector would run the request and compare the current access with the predefined security policy. And they would raise some violating accesses and to alarm the site administrator if there's something fishy going on. Finally, we also propose a policy generator that helps developers to come up with these security policies, because some of these policies could be hard to manually write. And in this talk, I'm going to focus on the visualizer and the policy. And due to time constraints, I will just briefly touch on the policy generator. And if you're interested, you can go and read the paper. So let's talk about the visualizer first. The visualizer is actually best explained by using a video. So basically, you can see this is the interface for the script inspector, which is not very different from the Firefox browser. So basically here, we'll use autozone.com as an example. So here, let's first visit autozone.com. And in this example, I've already added 2 items to cart. As you can see on the upper right corner here, I've already added 2 items. And let's click on that, and it will lead us to the shopping cart page. And you can see I've added these 2 items. And now let's actually use the visualizer on the left side of this panel to see what third-party script has accessed. So let's go ahead and do that, and it will display a list of domains. These are the third-party scripts that exist on this page. And let's focus on this script from moneytape.net. And let's click the display all, which highlights all the resources on the page that's been accessed by the script. And you can see that the part number of the items that you've added to cart, the quantity, the price of it, including the total price of your cart, has been accessed by this particular script. So as a a third party or as a concerned user, we have no idea of whether this is actually the intended behavior by AutoZone.com. But this visualizer gives the user or the site administrators an idea of what is going on with all the third-party scripts. So we're actually also be able to confirm that scripts from moneytape.net actually sends this information away to moneytape.net, and this is captured by a Fiddler, the traffic capturing software. So you can see the price and product ID and quantity are being sent out. So basically, this is how Visualizer works, and it gives the site administrators the better idea of what's happening on the page. So moving on to talking about the security policy that Script Inspector supports. The Script Inspector must support a security policy that has these several goals. So basically, the most important part is that the policy language needs to be very robust. So this is to avoid false alarms when the page content slightly changes or if there's a new page being added to the site. So let's say if eBay.com has a new item listed or NewYorkTimes.com have a new news page, we don't want to redefine the policy all the time. And then it also must be very, very accurate so that we don't make the policy over permissive, so that it must follow the principle of least privilege. And then finally, the policy should be expressive so that we can use the least amount of effort to create the most expressive policy to minimize the developer's effort. So let's actually look at a policy example of Google Analytics. So this is actually all Google Analytics does across all sites and all pages, embedding it. So I'll explain individual entries in more detail, but let's just give it a general overview here. So you can see that it reads certain part of the DOM and write to the head or body element, and then access some navigator object properties and also a cookie and then network. So let's focus on one of these entries. This particular permission allows Google Analytics to read the client height property of the body element. So this is basically allowing Analytics to read how tall your document is. The other permission shown here means that the Google Analytics can insert in the head element, but the argument must be a script that follows this regular expression, so it cannot be an inline script. Along with the network permission, this limits the domain or basically the domain where the script must be coming from. So this policy actually works across all sites and all pages, but sometimes there are cases where a policy cannot accurately describe and be adopted to all the pages. And this is because some pages would have advertisement or social network widgets that is embedded in different ways. For example, the /.org would have advertisements on the top. So there are two banner ads. There is a so-called skyscraper ad on the right. And then a different thing for ESPN, where they only have a square-sized ad displayed on the right, and then they will have Twitter feeds below that. Different thing for HuffingtonPost.com. So these ads and social widgets are all embedded differently. So a policy would not work across all the sites. However, fortunately, we were able to find that if we're looking just at pages within one site, for example, the upper two screenshots are Huffington Post, different news pages, and the bottom two are screenshots from /.org. So you can see that these layouts of advertisement or social widgets, they actually follow a pretty consistent pattern. So basically, because of this observation, we're able to propose site-specific policies. So these policies only apply to that site, but all pages within that site. So the site-specific policy is used to augment the base policies when necessary. And this is an example of Chulia.com embedding Google Ad Services. And you can see that they have certain policies about inserting content into certain ad placeholders. So here they have four placeholders, and then it would also need to read some location or size information about the ancestor elements of that placeholder. Okay, so let's move on to talk about the policy evaluation. So basically how effective are the policies and how much effort the developers will need to make to write these policies. So we took, like I said, top 1,000 websites, and we basically crawled these websites and found 25 most widely embedded scripts. And then we randomly selected 100 sites inside this top 1,000 site that embeds at least one of these 25 scripts. So this left us with basically a list of sites and lots of pages within the site. So here we used a crawler that runs Script Inspector for a duration of 40 days. And then whenever an alarm is raised, this would be inspected by me. I'm acting as a site administrator for these 100 sites. And then I will see if this alarm is indeed intended behavior, acting as, again, their site administrator. For example, if there's an ad showing up, I will add that to the policy, and then I will continue to run experiment. So this will give you an idea of how many alarms has been issued over the duration of 40 days. So on average, we get about 450 requests for each site, and the red dot would mean that there is an alarm issued by the Script Inspector. So if you are careful here, so basically a lot of the alarms are actually popping up on the left side of the screen, meaning that in the first 100 or so requests, you're going to see a lot of alarms, and which requires me to add more policies to the policy pool. So statistically speaking, if we have seen 100 requests about the same site, there are actually 71 sites in the 100 that we will not see any alarms issued in the next 100 requests. So this number will go up as we see more requests. So this is basically describing how fast the policy is converging to the complete behavior. There's also this list of all the third-party domains that we've investigated. And actually, if you look at the bottom part here, these Chartbeat and Google Analytics, these are all analytic scripts. So they would require the least amount of site-specific permissions. We're only concerned about site-specific permissions here because if the base policy for a script is basically a one-time effort that doesn't need a lot of site administrator effort, but the site-specific permissions would need each site to write their own. So analytics scripts, they do not require a lot of site-specific permissions, whereas the Google Ads or advertisement scripts in general, the social network widgets, because they're embedded in different ways, they require many site-specific permissions. But in general, there are 72 sites out of this 100 that require at least one site-specific permission. And the total number of permissions that we added is 436. This averages out to be around 6 permissions per site. So I'll give you an idea. Actually, this is the cnbc.com policy. This actually is exactly 6 permissions. So basically, the site administrators will need to write these policies when they want to use the Script Inspector system. So finally, before I conclude, we actually have the automatic policy generator available. This is to further reduce the developer's effort by basically taking inputs from Script Inspector, and then they will propose the policy candidates. And these candidates can be visualized by the visualizer again. And the site developer can approve these policies, edit these policies, and add them to the policy pool. But due to time constraints, I will be skipping this part. So again, all the tools and policies are available at scriptinspector.org. Actually, I will show a video about the policy generator, and I'll be taking questions during this video. Thank you.
Okay, we have time for a few questions.
Mm-hmm.
So nice work.
Thank you.
I think you can definitely draw some comparisons between what you've done here and, say, frameworks like CFP, right? Content security policy. So I'm wondering if you could maybe comment on, what the connections are and where your approach is different.
Sure. So CSP 1.0 actually is still quite a coarse-grained policy that basically enables a wide list of scripts or whatnot. And 1.1, of course, would have some more fine-grained policy control. But the thing is that we provide all these policy languages that you can use directory expressions inside the CSS selectors that can accurately describe what the ad placeholders are, and those I think will be helping the CSP. The CSP would not have that capability, and as well as our policy generator, which helps developers generate the policies, and that is also important to, I guess, complement the CSP as well. So, but the implementation of intercepting the API calls, as far as that goes, I think CSP and my implementations are complementary to each other. Yes.
So your policy generator, as I understand it, examines the accesses made during typical runs and generates a list of accesses. But what if sort of a more complex series of events are needed to, bring out accesses that are not typically the case? So,
yeah. So that's a very good question. So it's basically about maybe it requires some mouse clicks or other user events to see all the behaviors. So so for the evaluation that we did, we used the random clicks, or we attempted to do that, but there's no guarantee that we've actually discovered all the behavior. So that would be maybe we see more requests, or maybe we do more fuzzing on the simulated sessions. But I guess you're right. It's generally a very hard problem to ensure that we've seen all the behaviors.
So where I was going with the question is, so what role do you see your tool playing in someone trying to understand the integration of third-party sites in third-party scripts in their site? Do you say you will replace all existing analysis tools, static analysis tools, or is it more of an interface tool? So I'm somewhat unsure where in the space of mechanisms that elicit behavior your tool fits.
Yeah, so basically, I wouldn't say it's replacing the static analysis tool, but I think static analysis on JavaScript is generally a hard problem. But so this tool is more like dynamic, so because you run the site you actually go to that site and execute everything on that. So, but this would of course have the code coverage problem because you only see one execution. So I definitely wouldn't say it replaces the static analysis tool, but they probably can work together and to better help the developers make their decision. So
thank you.
Yeah, thank you for the question.
Okay, one more question.
Okay, my question was about what if these third-party scripts actually change after the administrator have inspected them?
Right. So that's also a very good question. The purpose of this work actually is to monitor the change of this third-party JavaScript, because they might be compromised by a malicious attacker, and then we do something malicious. So in that sense, this would actually catch the policy would actually catch the attack behavior. But if they are just changing, for example, the Google Analytics may update a version, and then during our 40 days of experiment, we actually did not see any, other than the site updating themselves, we didn't see actually behavior changes from the major scripts. They may be changing the detailed implementation slightly, but it's not affecting the API calls that we intercept. So the policy will still work for that new version. But in fact, if they do a major overhaul, to completely change their version, to update to a complete new version, then the policy might break, and the site administrator may have to retrain the policy. So, but we don't expect that to happen very often.
Thank you.
Okay. Let's thank the speaker one more time.